Hello and welcome to our technical webinar series. My name is Max Kraft and I will be conducting today's event. And today we're going to talk about using StarWind High Availability with Hyper-V and unlocking its failover clustering feature. I will begin with a brief overview of a basic virtualized environment and we'll see what it can offer us. Then I will show you the simplicity of becoming highly available with your virtualized production environment, and all along I'll explain the potential benefits of having fault-tolerant configuration in your production. After the short presentation we will have a live SAN demonstration, and I will show you how to configure StarWind HA itself, the cluster side, and how to make your virtual machine capable of performing live migration and make it highly available. So here we've got a traditional virtualization environment which runs a virtualization host and a pack of virtual machines which run on top of it. Well, all looks fine from the first glance. You manage everything within one box, you're happy with it, but as soon either storage or even the whole host goes offline, the headache begins. Imagine you have to restore everything from the hypervisor to a single file on the smallest virtual machine. Well, I wish you'd never get this kind of trouble. So death is cool till the first fault. The better practice is to have SAN-based infrastructure, which in pair with a failover clustering solution from pretty solid solution for the enterprise needs. What we have here is a basic configuration which can fit enterprise needs. We've got two virtualization hosts running virtual machines, and the storage is provided by a dedicated server which runs StarWind. So basically, even if one of the hosts goes offline, all the virtual machines will just migrate to the second host, and everything with no downtime, and your business will continue with no data losses or any PT errors. So the thing we need to do now, we need to ensure the high availability of our storage. So we've got two hosts, so the second will keep up if the first fails, but we need to add a second StarWind box, and this will make us really highly available, because even if one of the StarWind servers goes offline, all the production will not notice it at all. But let's end up with talking and get down to the most interesting part of our today's event. In a few minutes I will show you how easy and fast is the configuration of highly available storage resource for your virtualization needs. We'll export our highly available storage resource to a pair of Hyper-V servers, create a cluster from them, and see how our production environment continues working if we fail our Hyper-V server and even one of our storage nodes. Here is a StarWind management console. As you can see on the left, we've got StarWind servers listed. In our case, it's Star and Star2, the ports we use to connect to them, and the list of targets we have created, which now is clear. On the right, we can see the target lists, individual chat permissions, and access rights for the server. So in order to create a high availability device, I press Add Target button, specify the name for our target. First we need to create a quorum drive for our cluster, so I'll call it quorum. Go next, select hard disk, advanced virtual, high availability device. Here we need to type in the IP address or the name of our secondary StarWind server. It's Star2, and the credentials for the StarWind service. Press the next button. We can change the partner target alias if we need to. And here we specify the place where to keep our virtual disks. I will use the same place on both nodes. Tick the create new checkboxes and set it to be 1 gig. Go next. Here we have the data synchronization channel and heartbeat parameters. First, we specify the synchronization channel, which is a private link between two nodes used for data synchronization only. Any client connections, nothing else, pure iSCSI traffic. And the heartbeat. This is a new feature for the 5.5 version, which uses the client connection and is basically used to avoid split brain situations. So if the synchronization channel goes down, one of the nodes will determine what is wrong and just shut down itself or the partner in order to prevent split brain and data corruption in your production environment. Now we press the next button. We've got 4 initialization methods here. We can either clear everything or synchronize partner server with the local one, and the opposite option. These two are used for restoring HA if one of the servers is completely offline and needs a long-term repairment or is completely dead. And we have an option not to synchronize virtual disks, which I'll use here. Go next. The default mode for the high availability device is write-back caching. Write-back caching is protected against power outages because the data is written to the cache and it's only reported at successful write after the data is cached on both nodes. So if it's cached only on one node and this node fails in that moment, you will not lose any data. We can also specify cache size in megabytes and its expiry period in milliseconds. I'll leave this as default and press the next button. A short summary of settings we've provided here. Press next and finish. Okay, as you can see, we have created 2 targets, one for star server and one for star2 server, quorum and quorum partner. Now we need to do the same to add the storage high availability device, which will be used for keeping our virtual machines data. So now let's move to our cluster side and configure our Hyper-V hosts for working with StarWind High Availability. Here is our first Hyper-V node. I have already installed the Hyper-V role here and the failover cluster feature and the multipass I/O feature. Also, I have configured the MPIO for recognizing the iSCSI devices. In order to do this, you need to add this string into Discover Multipass. It will also be available for adding as soon as you add first iSCSI device in the iSCSI initiator. It will appear in this line. You just tick Add support for iSCSI devices checkbox and press the Add button. After this, you will be prompted to restart the server, and that's all for setting up HA on Windows. So what I need to do now, I go to iSCSI initiator. At discovery, I've got our 2 servers added with 3260 port, which is default one. What I need to do now, I just click the refresh button and connect to all of our 4 targets here. Now we go to disk management and we need to bring online our new disks and initialize them. In order to pass cluster validation tests, we will also need to create simple volumes on them. Finish. The next step is to connect the high availability device on the node 2. As soon we have connected our high availability device to both of the Hyper-V hosts, we can create a cluster from them. So I just go to failover cluster manager and press the create cluster link. Here we add our two Hyper-V host names. It's HV1 and HV2. And press the next button. I'll specify the cluster name, for example, Hyper-V1, and set the IP address to 192.168.0.32 and press the next button. So we're ready to create the cluster. I have already validated the configuration before. It has no warnings and no errors. So I just press the next button and wait until the cluster is created. If the cluster is created, we just press the finish button. The next thing we need to do after we have created our cluster is to enable cluster shared volumes. Just tick this link, check the checkbox, and press the OK button. Next, we need to add our storage drive to cluster shared volumes. We just press Add Storage button and select our drive here. As you can see, it is our 20 gig data store which we have provided by StarWind HA. Okay, we're all set. Our cluster is configured. We have cluster shared volumes enabled. So the next step will be creating a new virtual machine. So let's go to Hyper-V Manager on the local server and create a new virtual machine. Let's call it VM1. Yeah, it's critical to store it in the cluster shared volume. It appears as a mount point on the drive C of your cluster in the cluster storage folder under volume 1. If you add additional HA devices or any shared resources to your cluster, it will appear as volume 2, etc. So we select volume 1 here, go next, give it half a gig of RAM, connect it to a local area network, and give it something like 12 gig of storage. Will be plenty enough for it. And specify the location of our Windows installation images and press the finish button. Okay, now our virtual machine is created. Next step will be adding it to services and applications. We'll configure it to be capable to perform live migration. Select our virtual machine, press the next button, validate it for high availability. Okay, so now everything is set up and we can start the demonstration of the high availability. Now we'll power on our virtual machine and start installing the operating system on it. This will be used as a reference of high intensive disk load, and during the installation process I will just terminate one of the connections to the StarWind HA nodes. So let's connect our virtual machine. And here comes the configuration process. I will cut this out and resume the recording after the installation process is started. Alright, now we're ready to start the installation. I just select our single hard drive and press the next button. Okay, now the operating system is copying the install files to the hard drive, and I will open a remote desktop connection to our StarWind HA node 1. As you can see, I've opened services here, and we've got StarWind service started. So just in a few moments I'll stop it to show how the high availability solution from StarWind handles a failover. And stop. Boom. Now let's go to our StarWind management console and refresh it. As you can see, we've lost connection to the primary server. StarWind management console reports that connection is lost, but our virtual machine keeps working and is not even aware that storage is half dead. As you can see, it's not a picture. We can interact with it. So now let's handle a failback. I'll reopen the remote desktop connection, start the StarWind servers back. Okay, and go to the StarWind management console. Log into it. And just wait a few whiles while the targets are connected back to each other and start the automatic synchronization process. StarWind is now connecting to the secondary server. As you can see, it has already connected to its partner. And the partner itself handles all the read-write operation from the virtual machine in this time. Here we got the synchronization status appeared. The devices, you can see synchronization progress bar. Oh, our quorum drive is already synchronized, and the storage drive is now synchronizing. It's already 50%. Oh. And 80. As you can see, this synchronization is very fast. Using write-back caching with synchronization also provides it benefits. We have handled the failover, and what we will do now, I will fail our primary StarWind server once more, just after the synchronization is finished. Okay, synchronization is finished. Both of the nodes have clients connected, so we're back to usual configuration. And I'll stop the StarWind service one more time. And now we're gonna put some more intensive load on the virtual machine and on the StarWind service. I will just live migrate the virtual machine to another node. Yeah, StarWind management console reports that the connection is lost, and okay, the service is stopped now. Let's look on our virtual machine. It's already migrating. Okay, we'll now reconnect to it from the second node. Oh, and here's our virtual machine. Happy and productive. And now we'll handle a failback. Okay, StarWind service is now started. Log into the service in the primary node. And wait a while until our targets are resynchronized. and the storage started resynchronization process. Meanwhile, virtual machine doesn't even know what's happened with our storage. Then it's migrated to another destination source. So as you can see, by the help of StarWind HA, our failover cluster has become a fortress which doesn't fear any failures or breaks. So even if when the half of the configuration is that you have one Hyper-V host down and you have one StarWind HA node down, your configuration keeps working.